So let's move on to the next question, which is top k frequent elements. Okay, so you can read the questions. It basically means that we need to return a vector of answer in which we put the elements whose frequencies are the most, and we put k such elements. So in the first example, there is 1 which is 3 times, 2 which is 2 times, and 3 which is just 1 time. So the top two frequent elements in this case would be 1 because it is 3 times and 2 because it is 2 times. Okay, so the first thoughts which I am getting by looking at this problem, so whenever I see something like top k, I know that this can be solved using heap. But now, let's not just directly move to that solution. Let's understand it and think of the very brute force approach which comes to our mind. To me, what it comes is that I might need to keep a track of the frequencies of each element, which I can do by using a map. Then, in the first examples, I will have something like 1 will give me 3, 2 will give me 2, and 3 will give me 1. So the number and the frequency of it. So now, after the map is given to me, I can create a vector of vector in which I will copy these values. So I will put the frequency first and then the number itself and have it as a pair. Once I have it as a pair, then I can sort them. Once I sort it, then I will iterate and I'll sort it in a descending way, such that the most frequent element is at index 0. And then I will extract the first k elements through it. So this is a very naive solution. The time complexity of such a solution would be, firstly we will iterate to get the frequencies of all the elements, which will result in big O of n, and then for the vector we'll store every element from our map, which will take big O of n, and then we will sort the vector, which will take n log n, and then we'll just extract the first k elements. So the overall time complexity of such a solution would be n log n. Can we do better than this? That's where the heap comes in the picture. So now for the heap, what can I do? I will follow the same structure, but instead of sorting the whole vector, I will just push my elements in my priority queue. You can take any priority queue. Let's say that you take a max priority queue. You're following the max heap approach. So by definition of max heap, the highest value is at the top of the heap, top of the data structure. So let's say that after we have made our map, we push that in our max heap, by putting the frequency as the first value and the number itself as the second value. So after doing this, what we will do is we will put 3 1 in top, 2 2 at second, and 1 3 at the third place. Now you can do the same approach. You can basically do extract the top k elements from the heap itself. But did it improve our time complexity? So any insertion in heap is basically equal to log n, and we are doing that operation n times. So the time complexity still remains n log n. So this did not improve our time complexity. Now let's look at a different priority queue. Let's go instead with the min heap. Now the property of min heap is that at the top there will be the minimum value, and at the bottom there will be largest. So what we can do is that once we are pushing in our min heap, the operation to push any element in min heap is also log of n. However, we are not concerned about the top values. We are only concerned about the bottom k values. So, whenever our heap size is greater than k, we pop, and popping is always done from the top of the heap. So the minimum element will be popped out. So if we follow this approach, what will be our time complexity? Since we are just inserting in a heap which will have at most of k values, the log of n gets converted to log of k, and our time complexity increases to log of k. So our overall time complexity in this solution would be n log k. Let's code it up for better understanding. So as I said, first I will keep track of the frequency. So for that I will have a map. Let's name it MP, and let's traverse through our array, and let's increase the frequency one by one. So this my map is formed. Now I need a min heap priority queue. So how to declare a min heap? I don't know if I remember it correctly, but let's see. Because we want to store both the frequency and the value itself in our min heap, we need a pair. This is how you declare a max heap. For min heap, we have to write a couple of other operations. One is this, and another one is the greater function. So we have defined our min heap. Now as I said, we need to iterate through our map and push the element in our min heap. So how do we iterate through our map? Same thing, auto it mp. Remember, the frequency is stored as a value in map, so it would be it.second. So I will write pq.push, and when you want to push a pair, you basically insert it using the curly braces. So you will write it.second and then the value itself, it.first. So why I put it.second first? It's because I want my min heap to sort according to this frequency value. That's why. And when the size of this heap is greater than k, then it means that I have one extra element. So the topmost element, the k plus 1th element, will always be the minimum of all of them. So we can safely pop it out. So now we'll just use our answer vector, and herein we will iterate through the priority queue, which will for sure have k elements only. So while our priority queue is not empty, what we will do is that we will extract our value, which is equal to my pq.top.second, and then we do pq.pop, and we basically push back our value in this vector, and then we return it. Let's run and see if it works fine or not. Okay, I might have done some. Okay, there is a bracket missing here. Okay, there is one more bracket missing here. Okay, we're good to go. Now let's discuss the time and space complexity. As I already discussed it before, since we are using a min heap, so this operation, the pushing takes log of n. This pushing takes log of n, and we are doing it size of map times. But we are also popping from our priority queue whenever the size increases by k. So this log of n gets converted to log of k, and our overall time complexity for this solution is n log k. And space complexity, since we are using a map and a priority queue, so both will have at most n and end, which is n plus n. So this will be my overall time complexity of this solution. Now, can we further improve on this solution? This got accepted. Can we further improve on our solution? Can we do something by which our n log k gets reduced to n? So another optimized solution, a more optimal solution, would be to use something called as a bucket sort. So what bucket sort means is that you have buckets, and so in this case, what can be our buckets? We can, since we want the most frequent element first, we want the top k frequent elements, so we will store our elements based on a list which store it by their frequency. To explain it in a much better way, let's code it up and then we will explain it together. Okay, so let's first declare our bucket. So bucket, I said the index of it can be a maximum, will be the frequency. So the maximum frequency in our nums vector can be such that all the elements are same. So it can be of n size. So I need the index of n at most in my bucket, which means that I will create a vector of n plus 1 size, where my n will be the nums.size. So now I have my bucket with me. The same thing I will do, I will iterate through my map and store, I will iterate through my map and store the frequency and the value at that of that particular frequency. So bucket of it dot second will be my frequency because my value is my frequency, and then I will write dot push back of it dot first. Why dot push back? Because it's a vector. How can it be a vector? So let's say, for example, in this example, instead of 3 ones there were 2 ones. So a frequency of 2 will be same for both 1 and 2. So we need to store both values 1 and 2. That is why I have put a vector here. That is why we are pushing the value at the second place. So now we have our buckets formed. So now one question. Let's say whatever will be the maximum frequency. On maximum it can be of frequency n. All the elements are same. Second max can be n minus 1. Third max can be n minus 2, and so on. So we are getting some idea that at least I need to write my for loop in such a way that my I goes from n and my I should be greater than 0 because that's the minimum index, and I want to decrement my I value 1 by 1. Now at a particular frequency there can be multiple values, right? So we would need another loop to traverse through this vector of numbers whose frequency is I. So we can write something like bucket of I. So this will tell me all the numbers whose frequency is I itself. And then I need a vector to store my result. So let's have my answer vector here. And then I will just do answer dot pushback of, what should I do here? Num, because that's my value, right? So basically I am trying to traverse the maximum frequency first, and then first I will go for n frequencies, then I will go for n minus 1 frequencies, and so on. And when do I need to stop? When my size is equal to k. So if my answer dot size is equal to k, then it means that I should stop. So I break out of it. But that's not the only thing we need to do. We also need to make sure if we write break here, we will just move out of this inner for loop. Then we will check for one less value there of I than it was previously. So either we can put a condition on this for loop such that our answer dot size should be less than k, or you can also in this break you can have a boolean flag variable, set it as true, and then have a check here. If your flag variable is true, you can break out of this for loop as well. Doesn't matter, it's up to you how you want to implement it. So we will have exactly k elements in our answer vector, and then we return it. Now let's see if it runs fine or not. So what will be the time complexity of such a solution? We used the concept of bucket sort. Let's look line by line. First, it's the same thing. We iterated through our entire vector for the frequency map. So it will be n for this. Then we are declaring a vector bucket of size n plus 1. And this is a vector of vectors. It's a two-dimensional vector. And then we iterate through our map and then push the frequency as the index and the value as an element in the vector. So this will also take an operation. Now you would say that when we come to this line, when we are pulling our numbers out from the buckets, we are using two loops. So would that mean that if it is a n square operation? Well, I would argue that's not the case. Why? Because let's say that all the elements were just one value. Let's take the first example itself for better understanding. Here, the highest frequency is that of 1, which is 3. So whenever this I comes to 3 value, it checks how many elements are there of this frequency, which is just 1. So it was just 1, and then we move on to 2, and for 2 also it's just 1. For 3 also it's just, for 1 also it's just 1. Now let's say instead of 3 3s there will be just two 1s. Instead of 3 1s there would be just 2 1s. So we went to 2 first, and then we are going through all the elements in that particular frequency. So we will have 2 values in a vector for frequency 2. Does that matter? Overall, we are traversing the same number of elements. So in total, it will be just from big O of n and also big O of n here. So instead of n cross n, it will be just m plus n. So that's why my overall time complexity improves from n log k to n. And what will be the space complexity? Well, we are using a map, so n for that, and a bucket vector so n for that. So that would be the same. Let's submit and see if it passes or not. Well, it does.